Okay, unit review. The cubed root of 250x to the 7th, y to the 9th, we have to simplify. Now, my game plan here, there's 4 parts to this test. There's simplifying when there's no adding and subtracting with radicals. There's simplifying when there is plussing and minusing. There's solving equations, and there's graphs. So that's 4 parts. Now, simplify each radical expression, okay? Now, you don't see plus or minus, so try to use properties of exponents with the 6 lines. Now, if there's a radical, you need to get rid of it. If there's a radical. So you put it as a quantity to the 1/3 power. You turn the radical into an exponent. So you have 250 times x times y. 7 and a 9 on the x. So we have 250 times x times y. So 1 times 1/3 is 1/3. 7 times 1/3 is 2 and 1/3. 9 times 1/3 is 3. Okay? Okay, so I have whole exponents at 2 and 3. Okay? Or no, don't do that yet. They're all positives, just bring them over. That's what I'm going to do. If they're all positives, I'm going to bring them over here. Now, if you have a negative, it's got to switch positions, but we didn't have one. So it's got a 2 and a 3. Now I'll do that. x2, y3. Then the fraction, we have a 250 to the 1/3. And then x to the 1/3. That's a whole, don't circle, that's a whole. These bottoms need to be dealt with, okay? So I look at my 3 list, 250 is not there, so I can't get rid of it the quick way, and x isn't there either, so they stay for now. We don't need this line if there's nothing on bottom, okay? We don't even have to work, we can cross it out without asking any questions. Okay, now, the whole exponents, we're good with those, but we are not good with the fractions. So we have cubed 3's, so we make one single cubed root. And inside I put 250 to the 1 times x to the 1. So x to the 2 cannot simplify, neither can the y to the 3. And then in the radical, go back here, you're going to want to circle the base number, because that's what we're going to try to simplify, but we won't try to simplify the variable. Okay, so I put cubed root and I put 250, okay, because it's just to the first, so you don't need to raise it to the first, it'd just be the same. Now I make 2 radicals. Okay, so 250, you'd start with 216, doesn't work. 125 does work, it's 125 and 2. So the cubed root of 125 equals 5. So we're pulling a 5 out here and a 2 in there. Done. Okay. Next one. I don't see any plus. I have the 4th root of 16x to the 12th, y to the 3rd. No plus, no minus. Simplify it this way. Now, if there's a radical, if you're using this, you want to remove the radical by making a quantity to the 1/4 power. So we're going to have 16 x12, y3. Okay, so we have 16 times x times y. So 16 with a 1. 1 times 1/4 is 1/4. Okay. 12 times 1/4 is 3. 3 times 1/4 is 3/4. Okay. All of them just come over. They would not be changing positions. Okay. The whole comes first, followed by the fractions. Now, that's a whole. The fractions, we look at the bottom. We want to get rid of that bottom. Now, the easy way is to look at your 4/16 air homes. It's 2. So that is now 2 with a 1 power. Put that up there so you see it. You take whatever power's on top. That's still a power, but it's now a whole. And y, we can't get rid of that one. Okay? We'll have to make that into a radical down here. We don't need to mess around here. So that's a whole. That's good. That's a whole. That's good. That's got a fraction, not good. So you delete it, make a 4th root out of it, and x to the 3rd. Okay, 2 to the 1st is 2. And then x to the 3rd, and then the 4th root of x to the 3rd. Okay, number 3, we have the cubed third root of 9y to the second times the third root of 24y. Now, I never said plus, I never said minus, so here we go. Okay. Now, first you need to get rid of the radicals. They are the same radicals, so you make 1 parentheses to the 1/3. Then we take 9 times 24. 9 times 24 is 216. Then the y second times the y to the first, I add the powers and it's y to the third. Okay, y3. So you have 216 times y. And then 1 times 1/3 is 1/3. 3 times 1/3 is 1 whole. Okay, neither one of these are negatives, they're just coming over. The full exponent, y to the 1. Then the rational exponent, you want to underline the bottom, so we're fine with the whole. We check, got to get rid of that 3 somehow. So here's, I can get rid of it very easily. It's equal to 6. So that's the cubed root of 216, that equals 6, so we have 6 to the 1 power. Okay, and I don't need to do anything here. Now, that's a whole, it does not need a radical. That's a whole 2, it does not need a radical, so no radicals. 6 to the first is 6 times y to the 1. You can just put y if it's to the 1. Okay, number 4. Hint is there for you. It's not to confuse you, it's there for you. Got the square root of 3 times the third root of 3. Hint, we need to separate these, by the way, you're making your 6 lines. Hint is there, that tells you can't multiply the 3 and the 3. Okay, you need 2 parentheses, one with a 1/2 and one with a 1/3. A 1/2, a 1/3, and you put 3 and 3. You will not be multiplying your 3's, okay, because they're to different powers. What you are going to do is recognize that you have 2 base 3's where you add the exponents. So 1 plus 1/2 is 1/2. 1 times 1/3, sorry, my bad, I think I said 1/2 plus 1/3 is 5/6. Okay, so we have base 3 to the 5/6 power, so all you have is the fraction exponent. Now you got 6 on the back, 3 is way too small, okay, so it stays, but it's not on bottom, so, okay. Now, you may get rid of that 6 by creating a 6th root, and you put 3 to the 5th power. That easy. Now you make your 6th root, and you just have that number base that you need to simplify. First, we got to figure out what the heck 3 to the 5th is. 243. Now try breaking that up. So pretty much it's 64 broke. I mean, it's just easy. It's not a bad thing if you can't find it. You just put it in there. Okay, done. 6 root of 243. Okay, number 5. We've got the square root of x to the 7th times the cubed root, the third root of, when I say cubed, that means 3. When I say square, it means 2. The cubed root of x to the 2nd. So, terminology lesson. Hint, we need 2 separate ones. One with a 1/2, one with a 1/3. So you put x to the 7th and x to the 2. Now you're like, do I get to cancel those? No, because they're different powers, okay? You'll be canceling eventually, but you got to get them out of their parentheses. So you got x on top, x on bottom. 7 times 1/2 is 3 and 1/2. 3 whole and 1/2. 2 times 1/3 is the fraction 2/3. Now minus 2, get rid of that, and minus 2/3. That is 2 and 5/6. So we have 2 whole and 5/6. Well, we know it's positive, so I write x to the 2 and 5/6 power down. Now we have a whole, so I write x second, and we got a fraction, so I write an x again with a 5/6 power. Circle that bottom. Now you can't get rid of the bottom by looking at your list. That isn't going to work. Okay, nothing. Okay, so that's a whole, no radical. That's a fraction. We cross out the 6, make a radical 6, and put x to the 5th. And I don't think I can simplify x to the second stays put, and the sixth root of x to the fifth, you can't do anything because there's no number base. Okay, number 6, we have a parentheses with 625 to the negative 3/4 power. Now, we are using the 6 lines, but this can be a little different because there's no radical. You don't need to rewrite it because we don't have a radical to get rid of, so keep it the way it is. So 625, 1 times negative 3/4 is negative 3/4. I think that has to switch positions so that we can then have a positive 3/4 power. We don't ever want negative powers. And we just have the fraction exponent. Now remember, we want to try to get rid of that bottom. Now look at your list, okay? Before you jump down here and think you have to do something here, look at your list because you don't have to. Since 625 is a perfect fourth root, it equals 5. So we have base 5 to the third power. Now that is a whole, okay? Now, so down here, we have a base on bottom, but its exponent is whole. Put an H if it's whole, a W. Remember, it's a fraction, you put R, and you have to do this. But that's a whole exponent now, because it was 5 with a 4, which is, it was 625, and fourth root of 625 is 5, but there's still a power of 3 that we put on that root. Okay, that is a whole. It is not going to a radical. And then 5 to the third is 125, and we need a 1 over the top of it because it's 1 over 125th. Okay, number 7, we have base x to the 1/3 power times base x to the 1/5 power. Once again, you don't have plus or minus. Once again, I don't have a radical that I need to get rid of. I take this expression from scratch and simplify it. We got x times x, so that means plus. So we have 1/3, 1/5. Eight over 15, okay? Okay, so that's coming over. I don't really have a list for 15, so I guess I can't get rid of it from looking at my sheet. Okay, don't have to do anything here. You do something if you have a fraction on the bottom. Okay, so we make a 15th root, and inside we put x to the 8th power. Okay. Okay, number 8. We have a parentheses, we have 16x to the 15th, y to the 8th. Now bottom we have 81x to the 2nd, y to the 16th. Okay, so, again, 6 lines. Now I don't have to, there's no radical to get rid of, so don't be putting anything, don't be putting your own fraction in that. Okay, so you have a base of 16 and 81. And then times x times y times x times y. So 16, 1 times 3/4 is 3/4. 15 times 3/4, okay? I should know that it's 11. 15 times 3/4 is going to be 11 1/4. You use your calculator if you don't know it. 8 times 3/4 is 6. 1 times 3/4 is 3/4. 2 times 3/4 is 1, okay? Or no, 1 1/2 actually. Then y, 16 times 3/4 is going to be 12. Okay, so you got to do some crossing out. So you subtract 1 1/2 from the 11 1/4. Okay, I'm pretty sure that's 9 3/4. Let's me double check. Yep. So 9 3/4. Then we're getting rid of the at y here, minus 6, that's 6. Okay, so 16 doesn't change positions. X does not need to change positions. Then the 81 it stays in its position, and the y to the 6 would stay in its position. So you got a 9 and a 6 as your whole exponents. X as another exponent, but for now we put the wholes. Then I put my fractions, 3/4, 3/4. This has a base of 16. And this has a base of 3/4. Down here you got 81 to the 3/4. Circle them bottoms, okay? Now check your 4 list, see if you can get rid of it just by looking. If it's a perfect fourth, then it's no longer a fraction. 4th root of 16 is 2. So we have 2 to the 3 powered. So that 3 stays. It's now the exponent on what we got from here. Okay, 4th. So 4th root of 81 is 3. So 3 to the 3rd. And the 4th right there. Nope, X didn't go there. Okay. Okay, so we have a base on bottom, but it has a hole. This has a hole as well, so we do not have to use this line. Okay. So now, all your holes, you don't make radicals. That's a hole, x to the 9th. That's a hole, 2 to the 3rd. That's not a hole. You need to now cross out that 4, put it into a radical 4, and inside you put x to the 3. Okay, that's a hole, and that's a hole. Now, pretty much the only thing to do is simplify the 2 to the 3rd and the 3 to the 3rd. 2 to the 3rd goes to 8. The x to the 9th can't simplify. Inside the radical, you can't simplify because it's just a variable to its power. 3 to the 3rd is 27. Y to the 6. Okay, next one. Now we're back to actually having radicals. There's no plus, no minus in that expression. So, my base, okay, first thing, you have radicals to get rid of. Now you actually have to write it. They're both 2's, so you don't need 2 separate parentheses. You make 1 parentheses to the 1/2 power. Okay. You have an x on top, 6 times y on bottom. See, I didn't write hint because you don't have that hint. It's the same power. So you have x over 6 times y. So 1 times, and you can't simplify any of that. 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. Well, we're good in the sense that we don't have to switch anything to its opposite side because they're all positives. Okay. Now, we don't have any holes. These are all fractions. Okay, so bring them all over. But be circling the bottom as you bring them over. Get in that habit. Now look at your 2 list, okay? X isn't going to be here. 6 isn't. Neither is Y. So they're not perfect squares. None of those. Okay, where I can just cross them out. Now we have bases on bottom, and now they are not whole. They're rational. So that's why I wrote this thing here. Make sure the denominator is rationalized, meaning those rationals need to be made into wholes. Now what you have on top doesn't really matter at this point. Okay, it will in a bit. So you write your 6 to the 1/2. Now make it whole. Just make another base 6, another 2. 2 minus 1 is 1. But you got to multiply the top by that second one that you made up. And then y also has a fraction. We've got to make that whole. 2 minus 1 is 1. And you got to multiply by the top. Now, you don't multiply the 6's. It is not 36. You keep it at base 6. 1/2 plus 1/2 is 1 whole. You keep this at base y. 1/2 plus 1/2 is 1 whole, which is the point. Now we have holes on the bottoms because we don't want to put radicals in the bottoms. Now, this now need to be dealt with. They're all 2's, so if we can cross them all out if we make a radical 2. And in the radical, you got x to the 1st, or actually put your base number first, 6 to the 1st. Then follow with your variables, x1 and y1. Okay. Okay, so 6 to the 1st, 6. You can keep y to the 1st. Now you make your radical. You're going to circle the base number. You got x1 and y1. So I make a radical of a 2. Now it's 6 to the first, so it's just 6. Now I can make that. Now the only thing really on a 2 list, 6, I could even think about dividing by 6 is 4, but that's a decimal, so it's a decimal. You don't do it, okay? So you keep 6 in the radical. Okay, blank page. Now we got a game change, and it's for the better. This goes a lot quicker now. Now we see a plus operator. Well, now I switch my process entirely. No more 6 lines. You make sure you know your radical and look at the inside. And if it's the same, it's an easy problem. Okay? You write down the radical, combine your 4 and your 10. That's 14. Okay? Next one. 3 square root 20 plus 8 square root 45 minus, would be a plus negative. So we obviously have pluses. Okay? But unlike the last problem, the insides are not matching. Okay, so I come over here and simplify and try to get them to match up. So I have 3 square root of 20, 8 square root of 45, and then negative 4 square root 5. So I'm looking at my square root, 3 times square root times square root. Now 20, you would start at 16, which fails. Then 9, which fails, then 4, which works. It's 4 and 5. So square root of 4 equals 2. And we have 3 times 2 times the square root of 5. So that now is 6 square root 5. You're gone. 6 square root of 5 replaces you. Then drop your 8, okay? 8 has nothing to do with the radical breakdown, but whatever comes out of the first radical has to be multiplied by 8. So 45 divided by 36 decimal, 25 decimal, 16 decimal, 9. 9 and 5. So square root of 9 is 3. So you have 8 times 3 times the square root of 5. So we now have 24 square root 5. You're gone. 24 square root 5 is in. Now this last one, 5 divided by 4 doesn't work. So then what we do is nothing. You keep it the same way. So now all the square roots are matching. So square root of 5, so I take 6 plus 24 is 30, and then plus negative 4 is 26. Totally different ballgame, okay? All right, this little hint off the side will be on the test. This is a FOIL problem, okay? By the way, put a 1 in front of that, okay? You need coefficients in front of your radicals. If 1 doesn't exist, you put a 1. I would rather minuses be plus negatives so you can see what the coefficient is clearly. Now I wrote a little hint, the staple machine got in the way. You need to break down that 3 square root 27. Okay, so I've given you that hint that before you FOIL, you have to break it down because you see 27 is not in simplest form. It's true, it's not a perfect square, but it can be divided by one of the perfect squares. And it's 9, okay? 9 and 3. So square root of 9 is 3. 3 times 3 is 9, square root 3. So we now have 5 plus 9. Don't put the little 2 in on a FOIL problem because we're not going to be FOILing with anything but 2's. Now it's FOIL time. So I take 5 times 4. I take 5 times negative 1 with its square root of 3. I take 9 with its square root of 3 times 4. And I take 9 with the square root of 3 times negative 1 with its square root of 3. Okay, so 5 times 4 is 20. That's in simplest form. 5 times negative 1 is negative 5 with a square root of 3. That's in simplest form. 9 times 4 is 36 with a square root of 3, simplest form. 9 times 1 is negative 9, but then you've got to multiply. You don't keep that at 3, okay? You multiply the 3 by the 3. That's 9. Keeping it at the same radical is an addition property. We're multiplying, okay? 3 times 3 is 9. Square root of 9 is 3. Now I saw people doing that when I assigned that assignment, and I see what they're thinking, but keeping it at the same square root's an addition thing. See, when we FOIL, we're multiplying, okay? So that's now negative 27. Now I'm adding. 20 to negative 27 is negative 7. Now we're adding, so now is when I just keep it as the square root of 3 and add the coefficients. Negative 5 plus 36 is 31. Okay. You don't add these either. You can't add a constant to a radical term. Okay, next one. I'm not a fan of a minus. Make it plus negative 1. You're still trying to match the inside zone. They don't match, okay? If you want to put a 1 there, you can too. It's not really like it's relevant, but the negative 1's important. So let's get our insides to match. They're both square roots. So just 2 of them. So you've got 1 with the square root of 8, negative 1 with the square root of 18. 1 times, okay? You're looking in the 2 list. Well, it's either 4 or bust. 8, I'm pretty sure, divides by 4. So we replace the 8 with 4 times 2. Okay, square root of 4 is 2. So it's going to be 1 times 2 times the square root of 2. So that's 2 radical 2. You can put the radical 2 in there. If it's a square root, you really don't have to. Then negative 1, and we break down the square root of 18. So 18, you'd start with 25, with 16 doesn't work, then 9 does work, 9 and 2. Square root of 9 is 3, so we replace that with 3, so we have negative 1 times 3 times the square root of 2, so that's negative 3 square root of 2. And mission accomplished, the insides are the same. And we combine the outs. 2 plus negative 3 is negative 1. Okay, so we've gone through the big 2 parts, and now the third part's equation solving. Okay, you're solving for x here. So it's a square root, circle the radical. Okay, now look at operations outside. You got a 3 times in front and a plus 3 behind it. So before you get rid of the radical, you have 2 operations. You start with a minus 3. Okay, you have to undo the adding and subtracting, then you divide by 3. You're not using PEMDAS rules there, okay? Solving equations is like the opposite of PEMDAS. Then you get rid of your square root with a 2 power. Minus 3, that's 18. So I have 3 times the radical 2 of 2x plus 6. Now divide by 3. And that's 6. So you have the square root of 2x plus 6. Then a 2 power. Gets rid of the radical, okay? So now I have 2x plus 6. And thankfully here it's just 6 to the second, which is easy. That's just 6 times 6, which is 36. So there's only one answer to this equation, because it's x to the first, and we apply linear properties at that point. So I minus 6 and divide by 2. So 2x equals 30, divide by 2, you get 15. Okay, number 15, 4 times the quantity 3x minus 3 to the 2/3 power equals 36. Now when I have a whole parentheses to a power, and that variable I'm trying to get to is in the parentheses, let's replace it with h, okay? And we'll bring back the 3x minus 3 later. And I'm going to put a question mark on this side, okay? Okay, so I have 4 times h to the 2/3 power equals 36. So I need to divide by 4 before I get rid of the exponent. So that's 9. Now I reciprocate the side, 3 over 2. Now, how would you evaluate that? Well, first off, you look up the square root of 9, and that's an even, so we will use both sides, positive or negative. So square root of 9 is 3. It's right there, plus or minus 3. Then it's to the 3rd power. all you do now is raise 3 to the third power. It's easy. 3 times 3 times 3, 27. You're not dealing with radicals because you got rid of the radical right there. So 27, negative 27. So I plus 3, that's 30. And we get 10. Okay. Plus 3, we get negative 24. And we get negative 8. So those are each viable solutions. Okay. Then the last equation, we're back to having a radical, not a rational exponent. Okay, anything outside the radical you'd have to eliminate. No, there's no operation, so we go right to our 2 power. Okay. Eliminate. Now you put a 2 power to the other side. Now the side with the radical you don't FOIL, you just write x plus 6. But this side we have that binomial to the second, so we have to FOIL the x plus 4 to the x plus 4. X times x, x times 4. 4 times x, 4 times 4. So x second, 4x, 4x. Guys, these don't cancel out. They add up to 8x. And then 16. So then you have x to the second plus 8x plus 16. Now there are 2 answers. Now, because you have x to the second and you have some x to the first in there, you can't use linear properties, you have to use factoring properties, so you get one side equal to 0. That would be this side, clear. Minus 1x from 8x, minus 6 from 16. So we have 1x to the second plus 7x plus 10 equals 0. Now we factor the trinomial and use the zero product property. So GCF's 1, so nothing doing there. 1 times 10 is 10, positive. So we're adding to try to get to positive 7. So it's a positive times a positive. 1 and 10 does not accomplish that. 2 and 5, that does. Okay. Okay, make it 2 parentheses. 4, I'm going to be making 4. Okay. If I don't need the second 2, I don't need it. And a is 1x second. Okay. You don't need the 1. Be x. Then you don't do anything there. So we have rewritten that as x plus 2 times x plus 5 equals 0. Okay, so x plus 2 equals 0, x plus 5 equals 0. So I get negative 2, and I get negative 5. Okay, graphing. Graph the function, identify the domain and range. We'll do the D and R over here, but we don't really do that until I get my graph down. Okay, you're dealing with square roots. There are no cube roots on the test. So first, rewrite an equation as y equals with just the square root of x, and that's your parent function. So you can't have negative inputs into a square root. Well, then 1, 4, 9. So the square root of 9 is 3. The square root of 4 is 2, 1, 0. Now you got to translate. Do you have anything inside your radical? Well, there's an x, but there's no operation to the x, so that's a stay. Now outside, you have a times 5 and a plus 9. Okay? So 3 times 5 is 15, plus 9 is 24. 2 times 5 is 10, plus 9 is 19. And then 14, and then we'll be down to 9. Now if you want to check that, square root of 9 is 3. 3 times 5 is 15. 15 plus 9 is 24. Now, x can go by 1s, but the y-axis, we're going to have to probably go by 5s. Okay? 5, 10, 15, 20, 25. Okay, so 0, 9. That's your restriction point. You cannot go to the left of that. 1, 14. 4, 19. And then finally 9, 24. 9's at the end. 5, 10, 15, 20, 24. Now we keep rolling that way. Okay, that's continuous, but here's restricted. So you got 0 and 9. Okay. Seems to me like past 0 you go up with the other numbers, so that's a greater than or equal. Seems like after the 9 those get higher, so they're both going to be greater than. Or you can look at the graph. All points are to the right of the restriction point on the domain, so it's greater than or equal. All points are above the restriction point for the range, so that's greater than or equal to 9. Okay. Next one, number 18. Y equals, just put the square root of x and same ball game. Okay. 0, you can't have negative inputs into a square root function. 1, 4, 9, and then 3, 2, 1, 0. Okay, inside the radical we have an operation. Remember that has the opposite effect to your inputs. So plus 2, so it's 11, 6, 3, and 2. Now outside you have a plus 3. That has the same effect to your outputs. Outside operations do the same to the y. So it's going to be 6, 5, 4, and 3. Now graph it. So 2, 3, that's your restriction point. 3, 4. Shoot, I got to go by 2's, don't I, to get 0, 2, 4, 6, 8, 10, 12. Okay, so 2, 3. 3, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5, and then 11, 1, 2, 3, 4, 5, 6. So they roll that way. Now it's domain and range time. Remember, the x is the 2, the y is the 3. Okay, all points are going right, so that would be greater than or equal. And if I split it into a up-down half, all points again are above. So greater than or equal.